right. Hello, everyone. I hope you are doing great today. First of all, thanks to all of you for attending this webinar, and super happy that we are finally able to talk about Traefik v3, the latest version of the project. And first of all, let's introduce yourselves. I'm Emile Vauge, the creator of Traefik, and also the CTO and founder of Traefik Labs.
And I'm Nicolas Mengin. I'm Traefik maintainer, head of support at Traefik Labs, and I co-host this webinar with Emile.
All right. Before digging deeper into the latest version of Traefik, let's get back to the beginning. And this all started in 2015, so that's almost 10 years ago already. And at that time, I was a developer and working on setting up microservices platform. And as you might remember, in 2015, it was pretty early. The ecosystem was almost empty. Kubernetes was not here. Docker was super early. It was, it was pretty early. And I needed to expose automatically microservices on the internet. And that's how everything started. I started to work on the project, and the first commit came in August 2015. And that was the beginning of Traefik, the project. So yeah, what is Traefik at the end of the day? It's a reverse proxy, a gateway / an ingress controller. It has been made for the cloud native world, and it handles all the traffic management for your cluster, from the simple load balancings to the advanced canary release management. It handles the security aspect with, for example, TLS certificate management, and it handles, of course, observability of all your requests through tracing, through logs, through metrics, etc. What makes it stand out from other solutions? As I said, I've built it to be cloud native, so it is integrated with almost every orchestrator out there. It can be Kube, it can be Docker, it can be Nomad, whatever. Any basically cloud native tool is integrated with Traefik, and that's what makes it super useful. It is extremely lightweight, read and go, and everything is in a single binary, and it's extremely simple. So you can have access to advanced feature, but the user experience stay extremely simple. So I founded the company Traefik Labs and raised some money, and we've been able to release Traefik 1, the first major release. And we also have been able to hire a team and move to a new office with a giant Traefik logo, which was pretty amazing. Let's move to the next period, which is 2019-2020. We released Traefik 2.0, which was called Mondor, so the second major release of Traefik. And we closed another round of funding, and we've been working on the commercial product of our project, which is Traefik Hub. And the interesting part of Traefik Hub is that it's a superset of Traefik, the open source project, and it's focusing on exposing, securing, and managing all your services and your API. So it has really a focus on the API market. And if we dig deeper, the great differentiator of Traefik Hub is that it grows with you, starting from exposing your application and growing with you through your API journey from the application proxy to the API gateway with additional features like authentication, authorization, up to the API management, which is a bit more complex with API governance, API observability, and developer portal. Everything which helps you to manage API fleet. And finally, today, 2024, we release finally the third major version of Traefik, Traefik 3. And I also want to just get back to the crazy numbers of the traction of Traefik, because it's really an open source success story. More than 3 billion downloads, 47,000 stars on GitHub. It's in the top 15 most downloaded project on Docker Hub, which is kind of mind-blowing. And finally, most importantly, more than 700 contributors so far on the project. So clearly, it's not a project managed by a company, but it's a community project, and anybody can have some impact on this project. So I'm super proud of that. All right, so it's time to get back to the main topic, which is Traefik 3. So we will focus on key features that are part of this release. Of course, the release note is way more, way bigger than that. But those are the key features that we want to highlight. WebAssembly, OpenTelemetry, Gateway API for Cube, SPIFFE, HTTP3, also Tailscale. And let's start with OpenTelemetry and Nico.
Thank you, Emile. So Emile talked about microservices, and it's true that when you have to manage microservices on your infrastructure, observability is a must-have. So when we talk about observability and monitoring, we talk mainly about three kinds of data: tracing, logs, and metrics. So where the tracing helps you to monitor the performances of your infrastructure, to understand why, for instance, the traffic slows down with your application. It allows you to find bottlenecks, to solve the issue, to speed up the response time of your application. Here you can see a Jaeger UI. So Jaeger is a famous tool for tracing. So first of all, you can see what we call a trace. So the trace is the time spent by a request in an application. We can see here that this trace lasts more than 13 milliseconds in Traefik. A trace is split in many subparts named the span. Each span is a part of the application where the request pass through. So here we can see that we go into a rate limiter, and we spend most of the time in the reverse proxy part. We can say that because it's in dark blue, and dark blue is in Jaeger the critical path of the request in your application. Second type of data, it's a log. So logs allows you, as you know, to monitor the behavior of your applications, of traffic, of everything you have installed in your infrastructure. Having a central tool to monitor the log allows you to find easily the errors, to raise alert in the middle of the night, and to solve faster the issues. Because instead of having to use grep on a lot of files together, you have, like here, a low-key UI where you can see every log here from Traefik. So it's faster to debug and to solve the issues. And last but not least, metrics. So with an application like Traefik, metrics allows you to monitor your incoming traffic, to know how many requests are reaching your infrastructure, the rate of errors. It will allow you to scale up the number of applications, for instance, to be able to handle this incoming traffic, and then scale down when the traffic is back to normal. Here you can see, for instance, a Grafana dashboard. So in Traefik V2, we have brought support for many vendors because there are a lot of vendors for monitoring. And this is a difficulty because they are all different. For this reason, it has been decided to create a standard, and it's where OpenTelemetry comes. So OpenTelemetry is an open source project, a CNCF project. It's a merge between Open Tracing, which is a standard for everything around tracing, and Open Census, which is standard for both tracing and metrics. So OpenTelemetry brings specifications, but implementations too, because you will find SDK for many languages like Go. And another interesting thing brought by OpenTelemetry is what we call the semantic conventions. There are metrics and span that you have to provide if you want to say that you support the OpenTelemetry specification, but we will see it later. If you want to handle OpenTelemetry metrics and trace in your infrastructure, the recommended way is to install an OpenTelemetry collector. This collector will be in charge of importing data for the data providers like Traefik. In this hotel collector, you will be able to transform this data if you need it. And after that, the collector will export the data to your Prometheus, Datadog, or Jaeger. At Traefik, in Traefik labs, observability has always been very important. And in Traefik V2, for instance, we have brought the implementation of open tracing. That's why it was kind of natural and normal for us to bring OpenTelemetry support. In Traefik V3, we have brought the metrics, the tracing support, but not the logs one. Why? Because logs specification for OpenTelemetry is very recent. It seems to me it's end of last year, and the Go SDK implementation is still in progress. Of course, we take a look to it, and as soon as the implementation is ready, we will bring it in Traefik. But let's see a demonstration together. So for the demonstration, we installed a web server on a Key3s, which is a Kubernetes cluster, and a Traefik. So the web server display a sentence in ASCII art and some headers. And we have configured our Traefik instance to provide both metrics and tracing at the OpenTelemetry format. As you can see here, we have a direct access to Prometheus and Jaeger, because if using an OpenTelemetry collector is the recommended way to handle OpenTelemetry metrics and tracing in your infrastructure, for POC, demonstration, development, having a vendor direct access can be done and is enough. So now let's take a look to the web server. So we will go in the Traefik dashboard. And in this dashboard, we will take a look to our routers, and more specifically to the router named metrics.docker-localhost, which is the way to expose our web server. Here, as you can see on the right, we have added a middleware, a rate limit middleware. With this middleware, we will not only generate 200 response code, but as we will rate limit the access, we will send 429 response code too when the requests are rate limited. So now if we take a look to the Jaeger UI, we can see that there are different traces with more or less span and that last not the same time. This one is similar to the one we have seen previously, but if we extend a span like the rate limiter one, we can see that we are using the OTLP span format because it respects the semantic convention we have talked about previously. So we can see that this request passed through a lot of parts and spent a lot of time in the reverse proxy. A lot of time, it's less than 10 milliseconds, okay? And the response is a 200. It means that the request went well. Now, Let's take a look to another request, which is faster, less than 1 second, only 5 span. As you can see, the last span here is a rate limiter because this request was rate limited. And we can see if we expand here that the response code is a 429. We can have a Grafana dashboard too with OpenTelemetry metrics. So if we refresh it, the dashboard, you can see that we only have for the moment 200 and 429 as a response code. But what happens if our application shuts down? So let's just delete the pod. Now you can see that we will generate only 404. So if we go back to the Jaeger UI, it allows us to see that this request will be faster than all the other ones. Now we refresh here, and every time we only have 2 span, because at the beginning of the pipeline in Traefik, we detect that we don't have any backend for the rule, and we answer a 404. If we go now in the dashboard and we refresh the data, we will see that on top of 200 and the 429 response code, we have now the 404. Let's take a look to this diagram. We can see here that we are using HTTP server request duration seconds count, which is another semantic convention. So it means that, imagine that today you are using Nginx and you are using this data for your dashboard. After this webinar, you will use Traefik v3 and you will be able to replace Nginx with Traefik by keeping the same dashboard. So this is it for OpenTelemetry. And now let's talk about Gateway API.
Nico, before we jump into the next section, one thing, don't hesitate to ask any question in the Q&A box that you can find. We will answer everything at the end of the webinar. So if you have any question, don't hesitate to ask directly in the Q&A section.
Okay, let's move now to Gateway API. So with Gateway API, you are at 100% in Kubernetes because, as you maybe know, it's the next standard to expose services. So to understand why we need a new standard, let's do some history. And let's go back once again in 2015. So it's the year of the first commit of Traefik, but not only, because it was the beginning of Kubernetes and the ingress specification comes with it. So the promise of the ingress specification was to be simple and vendor neutral. However, this simplicity that should be its strength was its weakness, because it's not simple to expose an application. You just don't want to expose it. You quickly want to add headers, to rate limit the access, as we have done during the demo, to filter the IP. To do so with the ingress, you had to add vendor-specific annotations. So first, simplicity is promise is broken because annotations are not easy to maintain. And vendor neutral promise is broken too, because you have to use vendor-specific annotations. That's why in 2019, we have wrote our own specification, our own CRD, the ingress routes. It allowed us to bring support for TCP and UDP on top of HTTP, to create our own middleware object to ease the maintenance. Now you can define a middleware used by many ingress. And everything is defined using the spec section of the CRD. It means that everything is structured and validated. It's not the case for annotation, so it's simpler to maintain. It was beginning of 2019 with Traefik v2, and at the end of the same year, it was decided to start working on a new specification, on a new standard that go beyond the ingress specification. That's how Gateway API was born, and has been released in V1 at the end of 2023. Let's go deeper in Gateway API. So the main principle of Gateway API is to say that there is not only one person, not only one role to maintain a Kubernetes cluster, but many together. And on this screen, you can see we divided it in two kinds of people, ops and dev. First, the ops. In the Gateway API world, they are in charge to define what we call a gateway class. The gateway class refers to a gateway controller like Traefik. As you can see on the snippet on the right, we define the gateway class with a name, and in the spec, we set a controller name. Here is traefik.io/gateway controller. It means that every object that will be attached to this gateway class will use a Traefik instance to expose the workload. The second kind of objects managed by the ops are the gateway. Gateway objects are central in Gateway API because it allows you to manage the cluster access to reach the application. So gateway are defined with a name, and using the option gateway class name, they refer to the gateway class. So here, every object that will be attached to the gateway Traefik GW will be attached to the Traefik controller gateway class. It means that they will be exposed through an instance of Traefik. Still in the gateway, you define what we call a listener. The listener has a port to listen to catch the request and redirect them to your pods. So here we have named the listener web is a port 443 for HTTP, and every request for the hostname example.com can be handled by this gateway. Developers don't care about how it's exposed. They just want to expose their application. To do so, with Gateway API, they can use root. They can use HTTP root, TLS root, gRPC root. When developers define a root, the first thing is to define the parent ref and reference a gateway to expose the root. Of course, on the gateway side, you can define some policies or constraints to restrict the kind of root attached to the gateway or the hostname, for instance. On the root side, you will define a matcher to redirect the request and filters. Filters are operations you want Traefik does on your request when they pass through it. But let's see an example together. Here on the right, you can see an ingress. This ingress exposes the same web server as the one during the demo. And as you can see, instead of having a rate limit middleware, we added both header middleware and IP address to filter on the IP. On the right, so sorry, it was on the left. And on the right, you can see the same configuration using Gateway API objects. So the first thing we can see is that we have 3 annotations on the ingress side and no annotation on the gateway side. The 2 first annotations allows you to define the entry point, where here in Gateway API, it's done using the listeners in the gateway. Still on the ingress, we define another annotation to list the ingress, the middleware. In the HTTP root, everything is configured using the filters. Another thing, as you can see here, we only define one middleware because with the API, the Gateway API specification comes different kind of filters. There are core filters, which are operation a gateway controller has to implement, just like modifying the request. And on top of that, there are other kinds of filters, such as extension ref. Extension ref are all the filters, all the operations you can do using a gateway controller that are not part of the specification. So in Traefik, using an extension ref allows you to use every middleware already present in Traefik v3. So with Traefik v3, we have broad support for HTTP, TLS, and filter, but the feature is still experimental. It's experimental because, as I said previously, the v1.0 of Gateway API was released end of 2023. And we were about to release Traefik v3.0 SC1. For such a reason, we kept it experimental. But we are still working on it, and mainly working on the status reporting. That is a very important part of the specification. And our goal is to GA the feature ASAP, and hopefully in Traefik v3.1. So this is it for Gateway API. And now Emile will talk about WebAssembly.
Yeah, and I can share my screen if you want, Nico.
Wonderful.
Yep. All right.
I'm gonna wait just to be sure you can do it.
Yeah, and sorry for that. Okay, it's not ideal, but I don't know what happened. Everything was ready, and of course. Okay, let's go. So let's talk about WASM or WebAssembly, and let's start with the beginning of the story. So the need of plugins or extensions for Traefik, especially for middlewares, have been here for quite some time. And very early in the project, we had some discussions to build plugin. But to build that, we needed a plugin engine. And it's not that easy, and especially in Go. So the first idea, of course, was to use the plugin feature, the native plugin feature from Go, from the language. But that's exactly what we tried at the beginning. But sadly, we ended up with many issues. And mostly because the native plugin feature was not able to fulfill our requirement. So yeah, we had to find another technology, and at the end of the day, we ended up building our own technology. So that's how Yagi was started. And Yagi basically is a Golang interpreter. And the goal of Yagi was to build the best Golang interpreter, because there was already a few attempts to build an interpreter. But Yagi, yeah, was here to be the best and the most complete, to be able to be fully compliant with the Go specification. And that's what we did. And the project was extremely successful and has been integrated to Traefik to build the plugin engine. And this led Traefik to have dozens of plugins made by the community in its marketplace, in its catalog. So extremely successful. However, Yagi is a Go interpreter, and you have to be familiar with Go to write some plugins for Traefik. And not everyone is familiar with this language. Many people want to write a plugin in a different language, in JavaScript or whatever. And that's how the idea of integrated WebAssembly is interesting. So you probably already know everything about this technology, but just in case, quick recap. WebAssembly or WASM basically is a portable binary code format. And what's extremely exciting about that is you can generate a WASM binary from basically any language. It can be JavaScript, Java, C, C++, Rust, Go, whatever. And you can run WASM binary, on everything. It can be a browser, it can be a server. That's extremely flexible. So it's an open standard, and the community is extremely active on that project. So this moves pretty fast. It is extremely performant. To give you an idea, it's almost the same as native performance. So it's kind of mind-blowing. And it has many implementation. As I said, you can write some WASM binary. You can compile some WASM binary from pretty much anything and run that on pretty much anything. So extremely interesting. And it's also safe because the binary runs in a VM, right? So it is safer than just running an exec here. Pretty interesting, right? So the community came up with the idea of integrating WebAssembly to Traefik to build a plugin engine, to build a second plugin engine. That, I mean, I was saying at the beginning that the community had a great role in this project, and that's the best example. The WASM ID came up from the community and was built by the community in a very short amount of time. And I mean, I just find this extremely great because it's one of the most exciting feature of Traefik 3, basically. And to move forward, we wanted to build a great plugin example to show how WASM was, how powerful was WASM plugins, and what a best plugin than a web application firewall. So that's what we did. We integrated a web application firewall within a plugin, within a WASM plugin in Traefik v3, and we chose Corazza. They were close already to us building the WASM integration, and Corazza basically is an open source project under the OWASP Foundation, and the OWASP Foundation is basically handling security vulnerabilities and management on the internet. And Corazza is an enterprise-grade web application firewall. It's modern, written in Go. It is fully compliant with the mod security seqlang language, which is extremely interesting because that's what everybody knows. And it is 100% compatible with the OWASP core rule set. So extremely interesting. You can integrate core rule set directly into Corazza and directly into Traefik. So let's see how it works. And of course, it is, this new Corazza web application plugin is available within the plugin catalog. Let's see how it works within a demo. So we will first deploy Traefik, of course, and of course we will deploy Traefik with a plugin which is Corazza. So that's a WASM plugin, and as you can see, it's the same way to deploy a plugin with Yagi. We will also deploy a middleware, which is also a the Corazza plugin. For now, you can see that we have a bunch of configuration here, but at the end you can see sec rule engine off, which means that we load Corazza, but the engine is disabled. So yeah, the web application firewall is just disabled for now. Let's deploy an ingress route and to a vulnerable app that use the middleware we just deployed previously, and let's open the log following on this app. So this app is vulnerable to the Log4Shell vulnerability, which was discovered a few years ago, and we will inject a malicious request to this app. As you can see, we have a huge stack trace, meaning that the request hit the app and hit the vulnerability of the app, which is not great. Let's let's now instead enable the Croassa Web Application Firewall, and to do that, we will just switch on the flag on the config, and let's open the log again on the app. All right, and if we this time send the same malicious request, you will see that we won't even hit the app itself. We don't have any stack trace, any log. In fact, the Croassa Web Application Firewall just intercepted the malicious request and recognized that it was not great and just stopped it and sent the 403 error. So it prevent, as expected, it prevented any malicious request to send to reach to the app. So I mean, it's just great, right? It's extremely simple to set up, and you can have an advanced security within Traefik as a plugin. So yeah, congrats to the community to bring that to the to the project. All right, let's move to the next section, which is an important one because it talks about migrating and how we've been working on making it smooth, migrating from V2 to V3. And we have been following a simple philosophy. First of all, of course, it's a major version, so breaking changes are fine. It's okay to have breaking changes, but they have to be minimal and under control. So that's one thing. And the second aspect is that we want to provide a way to users to migrate progressively from their V2 Traefik instances to their V3 Traefik instances. We don't want to force users to upgrade all their ingress resources to the new V3 format. It would be a nightmare. So we have built a way to do it progressively, and let's dig into it. So first of all, you can have access to the detailed migration guide, where we list all the breaking changes we have that have been made to Traefik v3. And again, they are minimal, they are very targeted, but you have the whole list in this migration guide. So the thing is, we have made migration. I mean, the static configuration has to be migrated to the v3 format, because there are a few breaking changes in the static configuration. And once you have migrated your static configuration, you can just run all your existing ingresses. If you are on Kube or existing label on Docker, it will continue to run even with the old v2 format, because the dynamic configuration of Traefik v3 support both v2 and v3 format. So even though we have changes, we have changed a bit, a few things in the dynamic configuration, you won't have to necessarily migrate everything at once. So that's great, because it allows you to progressively migrate all your ingress to the new format. So super handy. And of course, lastly, as soon as we detect on v3 that we have a v2 option that is, deprecated, you will have some logs warning and explaining what you have to do instead, and linking to the documentation. So yeah, I guess we have made a huge work on that to make it as simple as possible. It doesn't prevent any, the fact that there are breaking changes, of course, in a major version, but we did everything we could to to make this migration path as smooth as possible. And there are, I mean, even though there are, I mean, as I said, the release note is huge. Let's dig deeper into a few more features. Nico.
Yes, because as Emile said, more than 100 pull requests were merged in v3.0. We talked about OpenTelemetry, WASM, Gateway API, but let's talk about a few other interesting features. Emile, if you can click, please.
Sorry.
So first, SPIFFE. So SPIFFE is a standard for identity control of applications. It's used MTLS system, and now with Traefik v3, you will be able to handle your certificate in Traefik to integrate Traefik in the SPIFFE flow. Other feature is HTTP3. So HTTP3 was already present in Traefik v2, but as an experimental feature. So now it's GA. We have brought Tailscale support. So Tailscale is a VPN that generates its own self-signed TLS certificates to allow the service to communicate together. And now in Traefik v3, you will be able to integrate these certificates in Traefik to expose the services in a Tailscale network. And concerning the compressed middleware, so we have provided a compressed middleware for a while, but only with gzip format. Now you will be able to use Broadly too. But don't hesitate to take a look in GitHub to the release note. You will have a global overview of the features we have brought with Traefik v3. But Emile, I guess you have one more thing to add.
Yeah, one more thing. And I read that a few of you have, I mean, I've seen that the demo we were showing were kind of blurry. So don't worry, we will share, of course, the slides and everything afterwards. So if you were not able to see everything during the demo, this will be shared afterwards. Yeah, one more thing. It is not, I mean, this is not a feature that is part of Traefik 3.0, but this is something we have been working on for quite some time, and I think this is pretty exciting. So I wanted to give you a few insights on what's happening here, and this has to do with performances, and let's just do some benchmarking. So we will set up a benchmarking infrastructure with 3 different servers. One server, which is a backend server, which basically run a simple web server, nothing crazy. We will add a gateway server, a reverse proxy, which will be either Traefik or Nginx. And on top of that, we will add a third server, which is the benchmark server, the client server that will use WORK to send thousands of requests every second to the backend server. Nginx will be used on the latest version 1.24, and Traefik will be used with 2.11, the latest 2x version, 3.0, and the special version fast HTTP that I want to talk about, that I want to showcase. And this special version is basically a revamp of the reverse proxy pipeline with some, let's say, memory allocation optimization. And let's see how it goes. I hope it will be less blurry. Okay, let's start Traefik 2.11, and we will also start WORK on this web server. So as you can see, we have 53K requests per second. Okay, let's start Traefik 3 and the same WRK request. No work, nothing has been made on the reverse proxy pipeline, so it's the same result, 54K requests per second. Let's now start Nginx, and as you might guess, Nginx is really a super fast reverse proxy, and we have a slightly better performance with 66K requests per second. And let's now start Traefik with the fast HTTP optimization. And what's interesting here is that we get 71K requests per second. So yes, that's better than Traefik 3, obviously, but that's also better than Nginx. So Nginx was 22% faster than Traefik 3, but Traefik fast HTTP is 77% faster than Nginx, which is mind-blowing. And it's even better if we compare to Traefik 3, which is 30% more performant. So yeah, to me, that's pretty crazy, because Traefik is not only the simpler or the most cloud-native reverse proxy out there, but it's about to be the fastest. So, I mean, it's kind of super exciting. All right, so that was it. Thanks a lot.